Hey everybody, and welcome back. Buckle yourselves up. This is going to be a treat. We are going to have a longer video today because this is going to be one of the topics that is going to be most important in this unit, and it's going to take a little bit of time to explain. I want to give you plenty of practice time as well. So make sure you got your notes out, make sure you're settled in, and let's do this. All right, so we are going to be dividing polynomials today using greatest common factor. We're going to be also using long division and synthetic division. The essential questions today: how do I divide polynomials using different methods, and then which method should I use? So the great question of, okay, what are the different methods, how do I do it, and then when should I use each one? In our last video, we talked about factoring polynomial using greatest common factor, grouping, and special patterns. Today, you might be using those factors to help you reduce division of polynomials down further. So to simplify polynomials when they're being divided. All right, so when we look at dividing using factors, we're going to use that idea of writing a polynomial in factored form and then seeing, do any of the factors cancel out with the divisor? So in the first one, x squared minus 3x minus 40, we would look at that and say, okay, the factors of x squared minus 3x minus 40, factors of negative 40, we need them to add up to negative 3. Well, that would be minus 8 and positive 5. So we would rewrite the numerator part, so the quadratic, as x minus 8 times x plus 5, and then it would be all over x minus 8. So then we could say, all right, well, the x minus 8s can cancel. This simplifies to be x plus 5. So that would be what the division would result in, which is perfect. And we will be looking at actual division very soon, so long division and synthetic division. If you use either of those methods, you will still get the same answer. So it's not like you have to be able to do this by factoring, but it can save you a lot of time. This is a much faster method than trying to do the long division or factoring using solving using synthetic division. On the second one over here, we have 8x cubed plus 125. Now, you should have like some little bells going off in your head being like, 8x cubed plus 125, that's set up very uniquely. That reminds me of something. And it should remind you of from our last lesson that this is 2x all to be cubed plus 5 all to be cubed. This is the sum of two cubes, which can be written in factored form. So that would be 2x plus 5. So remember the a plus b times a squared, so 4x squared, minus ab, so 2x times 5, 10x, plus b squared, so plus 25. And now this is all over 2x plus 5, so there my factors would cancel and I'd be left with 4x squared minus 10x plus 25, and then I could try and go, if I was asked to solve or anything like that, I could go do that. So be aware, our factoring situations from the last lesson, so all of those special patterns can come into play. Standard factoring of quadratics, which you've been doing now since Algebra 1, that can come into play. You may have to factor top and bottom. So like you could end up with a quadratic on top, quadratic on bottom, and they both just share one common factor and then the other one is not shared. And that could be something that happens too. So just be aware that that may come up. All right, so your turn. Simplify given the following expression. All right, so we've got x cubed minus 2x squared minus 8x all to be divided by x plus 2. See what you can make of that, come back, and then check your answer. Okay, welcome back. X cubed minus 2x squared minus 8x, they all contain x's. So that's my first hint. So that reminds me of having to pull the x out and see what's left. So x squared minus 2x minus 8 all over x plus 2. So x and x plus 2 don't cancel, so we're not there yet. Factors of negative 8 that add up to be negative 2. So factors of negative 8 that add up to be negative 2, that would be minus 4 and positive 2. So top line would be x times x minus 4 times x plus 2 all over x plus 2. X plus 2's cancel, so I'm left with x times x minus 4. Or they may ask you to, undistribute it, so to actually, to distribute it, so to unfactor it. And this would be your final answer. Either of these would work for me. So you can leave it in factor form, no problem. Okay, so we're going to start looking at long division of polynomials. Before we do that, let's go back to long division of numbers and see, do you remember like your elementary school math? So before calculators were really allowed, how did you do something like this? So 13,448 divided by 21. So the way we set it up, remember, is to do 21, and then you would have your division symbol, and you'd have the number inside of it, so 13,448. What you would do then is you would say, okay, 21, does 21 go into the first number 1? No. Does it go into 13? No. So then you look at 134. How many times does 21 go into 134? 21 times 5 would be 105. 105 plus 21 would be 126. So it will go in 6 times. So we put a 6 over that 4. So we'd say, nope, doesn't go in here, doesn't go in here. 6 does work. 6 times 121 is 126. So 6 times 121 is 126. We change the sign, we subtract it out. So we've taken 6 times 21 out of this. Now, technically, we're doing this in the hundredth spot. So we're saying there are 600 times 21 in 13,448. So there's 6 hundredths. Subtract it out, we're left with 8. And then you bring down the 4, so 84. And we're asking, okay, how many times does 21 go into 84? This one actually goes in evenly, it goes in 4 times. So then we would say, okay, 21 times 4 is 84. So subtract 84 out, we're left with 0, and then 8 comes down. We would say, how many times does 21 go into 8? 0 times. So 13,448 divided by 21 is equal to 640 with a remainder of 8. So sorry, not plus, that would be remainder 8. So there's 8 units that are not divisible by 21. Now sometimes you keep going and you would say, all right, at this point we would put in a decimal. So you have your 0 in here, comes down. How many times does 21 go into 80? It would be 3 times, so you would keep going. So that would be 63, so that would be 17. Doesn't go into it, so you add another 0, 170. So 21 into 170 would be what, 5, 6, 7 times, I'm going to say. So 7 times 21, 147. So it'd be 68. So we can do 8 times. So it'd be 8. So that'd be 168. And it would just keep going. So 2, so 20 would be your next number. So we get another 0, and it just keeps going. So that's where your decimals come from. So sometimes we write our answer as 640 plus the remainder of 8 still to be divided by 21. So there's 8 21ths. 8 over 21 left, and that will be your total number, or we say 640 with a remainder of 8. So just remember that those are slightly different. So the plus 8 over 21, that accounts for the actual decimal part of the answer. Remainder 8 is saying there are 8 units left over that still need to be divided by 21 if we were going to do that, but 21 goes into 13,448 evenly 640 times. So both important distinctions there for what we're going to do next. Forgot about that. Okay, so we've got some vocabulary that is important to identify. So quotient, dividend, divisor, and remainder. So where do these go in our, I guess, working out here? Now I need to erase all these zeros that I added in. Okay, so when we're looking at this, we would say the quotient is the answer. So the quotient is what you get when you divide two numbers. So that would be the 640. The dividend is the number that is being divided. So that's the numerator in our fraction. So this would be the dividend. The divisor is the number that we are dividing into it. That'll be 21. So divisor. And then the remainder is what's left over that cannot be divided evenly with the rest. All right, so typically when we write our answer, it's going to be in the form of dividend over divisor. So that's the question, is going to equal quotient plus remainder. Now you may get a scenario where I ask you to do like the remainder over the divisor as well. So just that, if it was a whole, keep going, like what would this actually divide down to be? You may see that come up as well. I will let you know if I'm looking for that though. All right, so long division of polynomials, we're going to set it up pretty much the exact same way, and then we're going to solve it down like we did the long division. You're dealing with x's though, so just be aware of that. It's a little bit different, but not a huge amount. So if that long division example is like, okay, yeah, I remember how to do that, then you'll find this relatively straightforward. If you have to really shake off some cobwebs on long division, then you're going to need to maybe do some practice of that before you even try doing it with polynomials. So if that's you, I would pause the video now, go find some long division practice, or just make up your own numbers. Like that's what I did for that example. I just made up a really big number and a small number, and I just said, okay, long division, go, and practice it over and over and check your answer using a calculator. So for this one, we would set it up, x minus 2 is the divisor, so x minus 2, and then dividend is 3x cubed. Now notice there's no x squared in here. So to make life a little bit easier for yourself, you want to have a placeholder for x squareds. So x squared, so 0x squared, it's not changing the value in any way, minus 2x minus 8. You'll see why in a second, but general rule of thumb, if you're missing any of the degrees of x, just insert it in there. So like be like, okay, there's a plus 0x squared going on here. So you have x to the power of 3, x to the power of 2, x to the power of 1, x to the power of 0 technically is a constant. All right, so let's get started. How you do it is you basically base your whole answer off of x. So you don't care about the minus 2. You're saying how many times does x go into 3x squared? Or what do you have to multiply x by to become 3x cubed? So we would have to multiply by 3 and an x squared to make that happen. So 3x squared times x is 3x cubed. The goal is pretty much to get the first term, or the leading term, to cancel out, and then you deal with the rest as it comes. 3x squared times minus 2 is minus 6x squared. So then we're going to subtract, so that means everything changes sign. So 3x cubed minus 3x cubed is 0x cubed. 0x squared plus 6x squared is 6x squared. So this is why we have that placeholder in there, so that we're able to just kind of keep going with our columns and not have to make stuff up. The minus 2x comes down, just like it does in numerical stuff. X times what is 6x squared? It's plus 6x. So 6x times x is 6x squared. 6x times minus 2 is minus 12x. We're going to subtract it, so that means both of them are going to change sign. So 0x squared, so the x squareds are gone. Minus 2 plus 12 is 10x, positive 10x. And then the minus 8 comes down, so we've got 10x minus 8. X times what is 10x? It's 10. So we've got 10x, and then 10 times minus 2 is minus 20. Subtract, so we're going to change signs. So we've got 0x, and we've got 20 minus 8 is 12. And x does not go into 12, so we don't keep going. We don't do like 12 over x or anything weird like that. We're done at this point. So we would say the answer here is 3x squared plus 6x plus 10. So this is the part that divided evenly with a remainder of 12. So remainder 12. If we were going to write it as an entire statement, so it would be plus, and then this is still over the divisor, so 12 over x minus 2. So that's when the plus would come in. If you're just doing remainder, it's just remainder 12. So you wouldn't do like 10 plus 12 in that case. All right, let's do another one. A little bit more, I guess, a little bit more complicated, maybe not, because we've got a quadratic as our divisor. It actually probably means less steps for us, to be honest, because we're doing x squared into x cubed, so we should end up with like a linear answer. So x to the power of 1 should be our quotient. So we set it up same way, x squared plus 3x plus 1 into 4x cubed 2x squared. So we've got all the powers of x accounted for. X squared times what is 4x cubed? It would be 4x. So 4x times x squared is 4x cubed. 4x times 3x is 12x squared. And 4x times 1 is 4x. We're going to subtract this, so everything's going to change sign. So the 4x, this should be a cubed. So 4x cubes cancel. 2x squared minus 12x squared is negative 10x squared. 3x minus 4x is minus x, and the 5 is going to come straight down to the end. So x squared times what is minus 10x squared? It's negative 10. So we got negative 10x squared. Negative 10 times 3x is minus 30x. And then negative 10 times 1 is negative 10. We're going to change the signs. So it's going to become plus, plus, and plus. 10x squared cancel. Minus 1 plus 30 is 29x. And 5 plus 10 is 15. So we're done at this point because x squared does not divide into 29x. So we would say this is 4x minus 10 plus 29x plus 15 all over the divisor still. Or we would say it's 4x minus 10 with a remainder of 29x plus 15. So new idea. I know this is going to be new, and this is going to take practice. Give yourself that grace and that allowance to say, okay, this may not make sense the first, the fourth, the fifth, the 20th time around, but it will make more sense the more times you practice this. And I have lined up a lot of Khan Academies for you this week to give you that practice. So we're only going to do 2 lessons this week, but you will have some Khan Academies to work on. You will have 2 weeks to complete those Khan Academies. So make sure you are dividing up your time well and getting all that done. So we're going to do 2 practice examples here. We'll do them one at a time. So your turn. Use long division and find the quotient and remainder. Pause the video, try it out, and then come back and see how you did. All right, let's see how it went. So we got divisor 3x squared plus 6x plus 1 dividing into 15x cubed. Now there's no x squared, so I'm going to put my 0x squared in here to hold that column placeholder, plus 8x minus 12. All right, so 3x squared to become 15. 3 times what is 15? It's 5. And x squared times x is x cubed. So 5x is that first term. 5x times 3x squared is 15x cubed, so that's the part that's going to cancel out. 5x times 6x is 30x squared, and 5x times 1 is 5x. And we're going to subtract all that out to see what's left, so everything's going to change sign. 15x cubed cancel, we get minus 30x squared, and 8 minus 5 is 3x, and then we've got a minus 12 coming down at the end still. 3x squared times what is 30x squared? It's minus 10. So minus 30x squared. Minus 10 times 6 is negative 60x. And minus 10 times 1 is minus 10. We're going to subtract, so everything's going to change sign. 30x squareds cancel. 3x plus 60x is 63x. And then minus 12 plus 10 is negative 2. So our solution here is when you divide them, you will get 5x minus 10, and the remainder is 63x minus 2. Or you could do plus 63x minus 2 over 3x squared. So you could write this answer as 5x minus 10 plus 63x minus 2 all over 3x squared plus 6x minus 1. So like in your unit test, for example, or in your checkpoints, I'll probably ask you to do both at some point. So I will leave you like spaces to type in like, okay, what are the numerical terms? What's the numbers being divided? So usually I'll ask you for like the coefficients of each of the terms, and then fill in the blanks. So that'll tell me if you know what you got or not. Or sometimes I'll say write quotient and remainder. All right, second practice problem. Take a shot at it, pause the video, come back, let's see how you did. Okay, so we've got divisor is x squared. Now for the divisor, you don't really need to put in like a plus 0x. I guess let's do it. It's going to give you a 0x every time you multiply. So I'll just show you what it looks like, but it's not really needed. It's only really in the dividends that we wanted, just to keep that column open for us. So we get 9x to the power of 4 plus x cubed plus 11x squared. We don't have an x to the power of 1, so I'm going to throw that one in there, 0x, and then minus 4. All right, so x squared times what is 9x to the power of 4? We need a 9, and we need another x squared. So 9x squared times x squared is 9x to the power of 4. 9x squared times 0x would be 0x cubed. And then 9 times 16, is that 90, 144? Yes. So we got 144 x squared, and that's all we got for now. So those are three terms. Subtract it, so minus 0 doesn't make a difference, and minus. So they cancel. We're still left with an x cubed, so x cubed minus 0 is still x cubed. 11 minus 144, so that's going to be negative 133 x squared. And then we're going to have plus 0x. All right, so we'll stop there for now because we're going to need the three terms. X squared times what is x cubed? It's x, so plus x. So x times x squared is x cubed. X times 0x is 0x squared. X times 16 is 16x. Subtract, subtract, subtract. So x cubes cancel. We get still a negative 133x squared. And then we've got a minus 16x and then a minus 4. X squared times what is negative 133? X squared is minus 133. All right, I'm going to run out of room here. Well, I'm going to run out of white space room. How does this work? No. All right, so just bear with me. I'm going to move this up so that we can continue our subtraction. 33x squared, 16x minus 4. All right, so 133 times x squared, so minus 133 x squared. 133 times 0x is minus 0x, and then 133 times 16. So that's going to be negative 2128. And then we're subtracting, so we're going to change the signs of all these. Cancels. So we got minus 16x, minus 4 plus 2128 is plus 2124. So there's my remainder. So my solution here is 9x squared plus x minus 133, and the remainder is minus 16x plus 2124. And don't be shocked if you start getting numbers like that are really big. It's going to happen just from the nature of what we're doing, dealing with different exponents and powers. All right, hopefully that went well for you. You'll be able to test these skills out again in our Khan Academies or in your textbook. There's going to be both options this week. Synthetic division. Now, this is a very similar idea, but it's going to be set up differently. So what we're saying is, all right, if we're dividing by x minus 2, we're saying if we evaluated this polynomial, so evaluate, remember, means that you would say, like if it was f of x, you would say we're going to do f of a solution, so a value of x, and then see what the answer is. The answer in our case would be our remainder. So x minus 2, the solution would be x equals 2. So what's the value of x that would make this 0? So we're checking to see if it was 0, but the answer we'll get left is our remainder. So what we do, this is kind of an odd setup. You take that value of x, the 2, and you put it in the top left-hand corner. And you put this like little backwards L around it. So this is how you know that's your divisor, so the 2. Instead of writing 3x cubed, 4x squared, 10, and so on, you're going to just put the coefficient. So it's going to be 3, 4. Now there's no x, so I need a plus 0x. This is important because you need to actually have every degree of x accounted for here. 0, and then 10. And then we draw like a subtraction line down here. So this is going to be an important part for us as well. The steps. The first number, so the 3, is always going to come straight down. Okay, so 3 comes straight down. Then what you do is you take the 3 that you brought down, you multiply it by the divisor. So it's going to be 3 times 2, which is 6. And that goes under the in the next available space above the line. So 3 times 2 is positive 6. So it's a positive 6. 4 plus 6 is 10. So then you take that 10, multiply it by positive 2. So 10 times positive 2 is 20. 0 plus 20 is 20. And then you do 20 times 2, and you get plus 40. 10 plus 40 is 50. And the last number, so when you run out of columns, you put an L around that one as well. All right, so what this tells us is that you've got, so the bottom down here is actually your quotient. This is our answer, and 50 is our remainder. And it goes up in degrees of x. So this is going to be your constant. This is going to be x to the power of 1, x to the power of 2. So it starts at like x to the power of 0, which is your constant, x to the power of 1, x to the power of 2. So our answer here is going to be 3x squared plus 10x plus 20, and the remainder is 50. Now, if you don't believe me, go check it using long division and try it out. You will actually get the same thing. So if you thought about like how we set that up with long division, it would have been x minus 2 divided into 3x cubed plus 4x squared plus 0x plus 10. The first value would have been 3x squared, and then you would have subtracted it down. So that would have been what? Minus 6x squared. So it would have become a plus, so it would have become 10x squared. And then so it would have been 10 would have been your next value, 10x. So it is, it's working out the exact same way. And we would have been left with a 50, which x minus 2 couldn't divide into. So we would be able to tell that x minus 2 is, so 2 is not a 0 of this function. So if you put 2 in for x, you wouldn't get 0. It would be, the coordinate for this function would have been 2, 50. So this is another way of evaluating a function. But it's also a way of doing division. So you get to see, well, if you took that out, what would be left? So if you factored out x minus 2, what would be remaining? We'll use synthetic division a lot later to try and find the zeros of a polynomial. So this is like kind of a build up to something bigger, but it is a method that we can use. So let's try one more and see, how it goes, and then you guys are going to try a few examples on your own. So if I'm dividing by x plus 5 is my divisor. That means that x equals minus 5 is that value of x that I'm going to use. So minus 5 is my synthetic divisor. 7 is going to be my first coefficient. There's no x squared value, so 0 is going to go in there for x squareds. Minus 6, and then 9. I'm going to draw my line, and the 7 is going to come straight down. So that's your setup. That's how you get started. 7 times minus 5 is negative 35. 0 minus 35 is negative 35. Negative 35 times negative 5 is positive 175, so plus 175. Minus 6 plus 175 is positive 169. 169 times minus 5, all right, I'm at the limits of my mental math, is negative 845. So then 9 minus 845 is negative 836. And that's the end, so that gets the remainder bracket. So that means the constant is 169, negative 35 is x, and then 7 is x squared. So our answer would be 7x squared minus 35x plus 169, and then the remainder is negative 836. So it is a faster method than long division, because it's very much just like down, multiply, down, multiply, down, multiply, and you're done. So if you can get your head around this one, you're going to find it much faster, and then we're going to need to get our head around it to test for zeros later. So make sure that you are not just kind of brushing this off. And we are entering a point, guys, where like Desmos is not very helpful to you. Your graphing calculator can't really do much for you. This is a part where you're going to actually need to learn the math and be able to do it. So that's why I wanted to only do 2 lessons this week. So make sure you are giving it plenty of time, and you're doing like the Khan Academy math task. This is going to run into next week as well. So turn up for the office hours, ask lots of questions. All right, actually let's do a third example and see if that helps kind of solidify this a little bit. If you get a fraction, that's one of the reasons why I wanted to do it. X minus a half, so that means x is equal to positive a half. Nothing really changes if it's a fraction. You can do it in decimal form if that's something that makes you happy, but doesn't really matter. So then we've got x to the power 4. There's no x to the power of 3. All the others are accounted for. So we've got 4, 0, minus 3 is the next coefficient, 7, and 2. And then I draw my line. 4 comes straight down. And even like to this day, I still draw that arrow for myself because it blocks me off from trying to do anything else. So that's part of like my routine for solving these using synthetic division. 4 times a half is 2. 0 plus 2 is 2. 2 times a half is 1. And it's a positive 1. So I like putting the sign in there too, just to make sure you avoid any confusion. Minus 3 plus 1 is negative 2. Minus 2 times a half is minus 1. 7 minus 1 is 6. 6 times a half is 3. 2 plus 3 is 5. So that means my solution is 6 is the whole number minus 2x, 2x squared, 4x cubed. So 4x cubed plus 2x squared minus 2x plus 6, remainder 5. So you saw how much faster that was than trying to do that with long division. Like doing the x minus a half with long division would be a little bit more tedious for sure. And in your test, I may ask you for the whole thing. I might just like say, okay, I'm going to do like your solution is going to be 4x cubed plus blank x squared minus 2x plus 6, and remainder is blank. And I'll ask you to fill in the two numbers. So like you'd still have to do the whole thing to get your answers, but you would have to fill in the two numerical values. So just be aware that it might look like that in your unit test or your checkpoints. All right, so your turn. Take a shot at it using synthetic division and see what the solution is. Come back and check out how you did. All right, so x minus 2, we're going to sub in x equals 2, so that's going to be our synthetic divisor. And then we've got 2x cubed, 5x squared, minus x plus 7, so all powers of x are accounted for. So we've got 2, 5, minus 1, 7. And put in our bottom line, bring down the 2. 2 times 2 is positive 4. 5 plus 4 is 9. 9 times 2 is positive 18. 18 minus 1 is 17. 17 times 2 is 34. Plus 7 is 41. So this means our solution would be 2x squared plus 9x plus 17. Remainder of 41. That's it. How'd you do? Second one, we've got 6x to the power 4 minus 25x cubed minus 3x plus 5 divided by x plus a third. Take a shot at it, pause the video, come back, and let's see how you did. All right, so x plus a third, so that means minus a third is going to be our synthetic divisor. We've got x to the power 4, x to the power 3. We're missing x to the power of 2, so I'm going to make sure I have a little note for myself in there. X to the power of 1, 5. All right, so we got 6 minus 25, 0, minus 3, and 5. And then 6 comes straight down. 6 times negative a third is minus 2. Minus 25 minus 2 is minus 27. Minus 27 times minus a third is positive 9. 9 times negative a third is minus 3. Minus 3 minus another 3 is minus 6. Minus 6 times negative a third is positive 2. And 5 plus 2, 7. All right, so then that means we've got minus 6, 9x, 27x squared, 6x cubed. 6x cubed minus 27x squared plus 9x minus 6, remainder of 7. So just a side note, synthetic division is only going to work when you have it down to a binomial, so x and a number, so you can actually get the numerical value of x if it were equal to 0. So you won't be able to do this with like x squared, or a quadratic or a cubic, so like we were doing with long division. So if you see one of those situations, long division is going to be needed. All right, so that brings us to the end, the big day in, I guess, our Algebra 2 lessons, because this is kind of where we really dived off into something new that you hadn't seen before. So how do I divide polynomials using the different methods? The first one we did was you factor any like quadratics that are in there, or look for those special patterns. So, you know, the sum of 2 cubes, difference 2 cubes, and then you see, do the factors cancel? So you factor everything, and then you see, are there factors that cancel? Then we did long division. So long division, particularly use long division if you're dividing, so the divisor is a quadratic, a cubic, something that's just not a linear function. And then synthetic division, you are figuring out for the divisor what would be the 0. So what's the value of x that makes the divisor 0? And then you're using that as your synthetic divisor, and you're listing the coefficients, remembering to put in zeros for placeholders for any degree of x that's not accounted for. All right, after today, so this is the first lesson in Unit 3, Module 2. So we're not going to do the rest of this module this week. I want to pause there, and I want you to start knocking out some Khan Academies. Now I put a lot of Khan Academies in because this just needs practice. You've also got textbook work options in your independent practice, so make sure you are doing both. Turn up for those 12:30 sessions, ask questions in class, make sure you're asking questions, because there should be questions coming up as a result of this. Watch the video through again, do the examples with me, make sure you're getting the same answer. Those are all great tactics for learning how to do this stuff. All right, I'll see you in class.